All right, we want to rationalize the denominator. You're not allowed to have a square root in the denominator. So what do? Well, we need to multiply this guy by something that's worth 1. Well, I can multiply by 3 over 3 or 5 over 5, but I need to do it so that I can get rid of that square root of 2. So I need to just do it by the square root of 2. Now notice the square root of 2 over square root of 2 is worth 1 because they're the same number. So it's only worth 1. So you're not changing anything really. So up top, I get 4 root 2. And what is the square root of 2 times the square root of 2? That's simply a 2. Now I do need to simplify because up top you have a 4, a number outside, and the 2. They both can be divided by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So this becomes 2 root 2 over 1, which is just 2 root 2. 2 root 2 is the exact same answer as 4 divided by square root of 2. Look completely different, but they are mathematically the same number. Here, how am I going to get rid of dividing by a square root of 7? I'm going to multiply by square root of 7 over square root of 7. Up top, I get negative 5 root 7. In the bottom, root 7 times root 7 is just 7. Can't do anything with the 5 and the 7. Again, you'll never do anything with the inner number in this guy down here. It's always going to be the outside numbers. And negative 5 and 7 have nothing by which they both can be divided. So we just leave it. There's our answer. Negative 5 root 7 over 7. A little bit uglier, to be honest, but that's what we have to do. No radicals ever allowed in the denominator. So here, I'm going to multiply by, you guessed it, root 5 over root 5. I do that so that when I multiply these guys together, it's a nice whole number, 5. Up top, what do we have now? 2. On the outside, a root 2 times root 5 is a root 10, and root 10 is nothing that can be simplified. 2 and 5 have nothing in common, so this is our final answer, 2 root 10 over 5.